Hello everyone, my name is Serge. Welcome to Xomega Videos. If you've been following the latest Blazor development in .NET 8, you may already know that it introduced a number of rendering modes for interactive components in an attempt to unify various Blazor technologies, such as Blazor Server and WebAssembly. This gives you more choices for configuring your Blazor solution and incidentally makes it more complicated, especially if you're just starting with Blazor. In this video, I'm going to show you how to quickly create business applications with Xomega using a unified Blazor architecture in .NET 8 without having to worry about the architectural decisions up front. If you like this video, make sure to hit the like button and leave your comments and feedback below. If you try to create a new project in Visual Studio and select the project type as Blazor, you'll see that there are only a few Blazor templates included by default. The Blazor Server app is an old template for Blazor Server projects that doesn't support .NET 8, which by now is basically the only version with the long-term support available. The Blazor WebAssembly standalone app is also an old template for creating standalone WebAssembly applications, but it does support .NET 8. Even though you can select individual accounts as the authentication type, it will merely set up authentication using a third-party identity provider that supports OpenID Connect, just like the Microsoft Identity Platform. The Blazor Web App is the new project template for .NET 8 only that offers you a selection of interactive render modes, as well as a way to configure the interactive modes either globally or per page or component. Configuring it per page or component could make your application quite complicated, so you're better off configuring it globally, unless you have some very advanced scenarios. While Blazor provides a common component model for building interactive web applications, each rendering mode is based on a completely different architecture under the hood that requires building applications in a very particular way. The render mode None is essentially a server-side rendering, similar to the traditional MVC and Razor pages. To implement interactivity, you have to use JavaScript and/or postbacks to the server, which generates the entire tree from each request and doesn't keep any state between requests. The Blazor Server rendering mode runs inside a Signal R circuit that keeps the current state of all the components. Instead of recreating the entire tree every time, it calculates just the differences that need to be applied to the browser's DOM, much like the modern version control systems allow merging changes from one branch to another. Just like with the server rendering, your Blazor Server code has full access to any server resources, such as the database, but it also provides interactivity by allowing you to call JavaScript right from the server-side code. There are also some downsides related to Signal R limitations. For example, if there is inactivity or if some unhandled exception is thrown, the circuit may get killed and all the user state will be lost. Another limitation is that you cannot set any response headers in your server code that runs in the circuit, and specifically authentication cookies for the current user. Therefore, if you select individual accounts as the authentication type, the ASP.NET identity pages that it adds for logging in, registering, or managing the account all have to use the rendering mode None with full server-side rendering. That code looks quite different from any other Blazor Server components, let alone components running as WebAssembly. Blazor components running in WebAssembly are always interactive, since they are running entirely in the web browser. While they are still run in .NET and use the same Blazor component model, they use a totally different architecture. The .NET code that you can use there is sandboxed by the browser. You have very limited access to the local resources, and any access to the server resources or a database is only available through a remote API via HTTP. This architecture is very similar to JavaScript-based single-page applications, such as Angular, React, etc. To run your Blazor application as a WebAssembly, first the browser needs to download all the libraries that it uses. The application and its libraries may get quite large, which could make for a slow initial download. There are some techniques for reducing that size, such as tree shaking, but this is where the auto-rendering mode comes into play. It allows you to start off instantly by using Blazor Server for interactivity while the Blazor WebAssembly libraries are being downloaded, and then seamlessly transition to the WebAssembly mode. In theory, being able to run the same components both in Blazor Server and WebAssembly modes sounds fantastic. In practice though, you have to remember that they use completely different architectures. Unless your components are very simple, you may need to use different methods to read or update the application data, or have different authentication mechanisms. The default Blazor templates give you like 25 different ways of setting up your application, but they create bare minimum projects, possibly with some basic sample pages, leaving it up to you to figure out how to develop a resilient and robust architecture for all these Blazor technologies. Luckily, the latest release in Xomega.Net for Visual Studio has a solution wizard that helps you easily configure your desired architecture and, more importantly, structure your solution projects in such a way that you don't have to worry about the architectural differences between the various Blazor technologies. Well, before you say, great, now there are 26 different ways of creating a Blazor application, let's see what it can actually do for you. When you install the Xomega.Net for Visual Studio extension, you will have a new solution template, which you can find by selecting the project type Xomega. Let's enter a name for our unified Blazor application and hit the Create button. What opens up next is the Xomega Solution Wizard, where you can pick the type of applications you are building, the projects you want to include, and the configuration of each project. Normally, any dependent projects will be included automatically, so you just need to select the top-level UI projects. The main Blazor project is at the top and includes both Blazor Server and WebAssembly by default. Notice how the Blazor WebAssembly project got automatically included, as well as a project for REST API that will be used by the WebAssembly to call the services. If you expand the main ASP.NET Core Blazor project here, you'll see that it provides interactive server rendering for the Blazor components and also hosts a Blazor WebAssembly application. Moreover, it also hosts the REST API for the WebAssembly in the same project, which allows it to use same-site cookies for authentication. You can uncheck it if you want the REST API to be hosted in a separate standalone project. In this case, the WebAssembly code will be making cross-site API requests, and the API will be secured using JWT authentication tokens rather than cookies. Notice also how the short project summary in the project header reflects its current configuration by taking out the API part. If you don't want to bother with WebAssembly and are perfectly content with the traditional Blazor Server architecture, then you can uncheck it as well. As you see, the Blazor WebAssembly and REST API projects got automatically deselected, and the configuration summary updated to just Server. Finally, if you want a traditional standalone Blazor WebAssembly application that is not hosted by ASP.NET Core, then you can deselect the ASP.NET Core project and select just the Blazor WebAssembly. This will also include the separate REST API project that will be secured with JWT. So there are plenty of combinations to configure your Blazor application if you know exactly what architecture you're looking for. But what if you are not sure which is the best architecture for you? Or what if you want to be able to change the architecture down the road without having to rewrite the entire application? Xomega makes it possible by having most of the application code in the shared Blazor components and reusable presentation logic classes or business services. If you don't have a specific architecture in mind, then the default selection with the auto rendering mode and hosted REST API would be a great choice as a starting point. This will set up all the projects for this configuration, but you will be able to adjust the rendering mode, as I will show you later in this video. If you click the preview button now, you'll have a chance to review and adjust the configuration of the selected projects. Let's go ahead and hit the Create button to generate a Blazor solution using our configuration. Our new solution contains a main ASP.NET Core Blazor project and a project that specifically targets WebAssembly. However, the bulk of the application's Blazor code is defined in the Blazor.common project that contains components and classes that are shared by both of these projects, which provide some wire-up code and implementation specific to the Blazor Server and WebAssembly technologies respectively. The main page of the app is described in the app.razor file. This is where the global rendering mode is configured, which is set initially to the advanced interactive auto mode that combines both Blazor Server and WebAssembly. Now, to better illustrate the difference between these rendering modes and how they are unified in our application, let's start with the Blazor Server mode by setting it to Interactive Server. Our solution is automatically secured with a password-based login view. This view is actually auto-generated from the Xomega model that I will show you a little later. But more importantly, it can run equally well in Blazor Server and WebAssembly modes, and therefore have the same programming model as the rest of the screens, unlike the authentication screens for individual accounts that the standard Blazor template creates, which only work with non-interactive server-side rendering. Our solution also includes the default home page, which doesn't have much but a welcome message. What I want to point out though is that it has an authorized attribute, meaning that you have to log in first in order to view it. Now let's run our application and see how all of this actually looks in action. As expected, we need to authenticate before we can access the home screen, so we have been redirected to the login screen. The Xomega solution template provided all the scaffolding for the password authentication and left for you to implement the actual validation of username and password. By default, it will accept any username and the word password as the password. It also pre-populated these values to help you skip the login screen during the development. Let's open the Network tab to see what's going on under the hood. If I refresh the screen, you'll see that there are two Signal R WebSockets running to support hot reload and another one for our Blazor Server application. If I enter an invalid password and try to log in, you'll see a standard authentication error, meaning that the screen actually performed password validation. However, notice that it didn't make any additional network requests, which means that it ran entirely on the Blazor Server circuit. Now let's enter the correct password and try again. As you see, we got our home screen and our authenticated user's name is showing in the top right corner. If you look at the Network tab though, you'll see that after this successful login, we were redirected to a sign-in endpoint with a secure authentication ticket as a parameter. This allows the login screen to set the authentication cookie, which it cannot set otherwise from within the Signal R circuit. We also have a sidebar menu, but there is nothing there other than the home screen, so let's go ahead and sign out. Notice that now we have been redirected to a sign out endpoint, which allows us to clear the authentication cookie. So far, we just saw a default Blazor solution generated for us by the Xomega solution wizard. Now let's get to more interesting stuff and see how we can actually build business applications with unified Blazor architecture. Our solution contains a model project that allows us to model domain objects, business services, and UI views, and then generate all the necessary artifacts from them. For example, as I mentioned before, we have a model for our login screen in XML format. If you collapse it to definitions, you can easily see that it defines a login view with a login object as a view model, as well as a business service with a login operation that uses some structures defined in the same model. To show you a more realistic example of building a business application, I'm going to import the Xomega model from a sample SQL Server database AdventureWorks by Microsoft. To do that, I'm going to expand the generators node in our model project, go to the model enhancement folder, and open up properties of the import from database generator. The database connection property allows you to pop up a dialog for configuring a connection to our sample database. I'm going to click the Configure button and select the AdventureWorks 2022 database on my local SQL Server instance. I'm going to include all tables in the import and then click Finish. To run the import, I'm going to right-click on the generator and click the Generate button. As you see, it added the import folder with model files for all database tables grouped into modules by their respective SQL Server schemas. Let's open a model for the employee object from the Human Resources module. The fields of our domain object represent the columns of the employee table. To allow managing employees in our business application, I'm going to create a couple of views. One for searching employee records and another one for creating or editing details of individual employees. Following best practices for multi-layered architectures, you don't want your views to access the database or directly manipulate the domain entities. Instead, you want the views to work through a set of CRUD operations to create, read, update, or delete the entities. These operations will encapsulate any business logic and will form the business service layer for your application. For any domain object, Xomega allows you to quickly add initial CRUD operations and views by right-clicking on the model file and selecting the Generate Model Enhancement Full CRUD with Views menu option. If you collapse the definitions now, you can easily see that it added Employee List view for searching employees and Employee view for editing their details. It also defined appropriate data objects that serve as the view models, as well as a set of business operations to read, create, update, or delete an employee, and to read a list of employees. Now, to generate all the appropriate artifacts from the model, all you have to do is to right-click on the model project and select the Build menu. In the output window, you will see all the generators that have been run as part of the model build. If you take a look at the project that contains business services for the application, you'll see that it has a generated employee service class now under the Human Resources folder, which contains implementations of all our CRUD operations. If you scroll up to our project with the shared Blazor components, you will also find our employee views generated under the Human Resources folder. Now let's run our updated application and have a look at the generated views. Once you log in and expand the sidebar, you'll notice that there is a Human Resources menu, which has views to browse employees and to create a new employee. Let's take a look at the Employee List view. By default, it allows you to enter criteria by any employee field and displays all the fields in the results grid. I'm going to open up the Network tab and run the search. Just like with the login screen, there are no network requests to get the data, which means that the read list operation was executed on the Blazor Server Signal R circuit. When I click on the ID of any employee, up pops a dialog for viewing and editing employee details. As before, the Network tab shows no additional HTTP requests to read the employee data, meaning that it still happens on the server circuit. Now that you understand the architecture of a Blazor Server app that runs all the components on the server and has full access to the backend resources, let's see how we can reuse all the code for a WebAssembly application, which runs in the browser and needs to call REST API for any business services. So I'm going to go back to the app.razor file and change the render mode to interactive WebAssembly. This should run our application solely as a WebAssembly, without any Blazor Server sockets. Even though we selected the option to host REST API in the main Blazor project, the actual API controllers are defined in a separate project, which also allows you to host it separately if need be. The initial project template included an auth controller for password authentication. Since the API is hosted by the main Blazor project, and therefore we can use the same site cookie for authentication, the auth controller provides an endpoint for cookie-based authentication. In addition to the auth controller, we've got a generated employee controller under the Human Resources folder, which exposes our CRUD operations as REST API endpoints. This will allow the WebAssembly to call our business services from the browser via HTTP. So let's run our app again and open up the Network tab to see what's going on under the hood. If I try to log in with the wrong password, you can see that now the login screen is trying to make a request to our cookie authentication endpoint, which returns a bad request status code. If you check the payload, you'll see the bad credentials that I submitted. Now, if you check the response, you'll see the error messages that the endpoint returned, which are then displayed on the login screen. Now, let me enter the correct password and log in again. This time, the API request was successful, and you can see that it also set an authentication cookie, which will allow it to call other secure API endpoints in the same browser session. Remember that had we used a standalone web API, we would have called an endpoint that returns a JWT instead. Notice also the username in the top right corner. This means that the authentication state has been properly set in the WebAssembly by the login operation. Let's open up our employee list screen. To help you better see it, I'm going to move the Network tab down to the bottom of the screen. Let me enter some search criteria, such as where login ID contains a string can. If I click search now, you'll see that it called our API endpoint to read the list of employees and pass the criteria in the URL parameters. Similarly, if I open details of an employee, you can see that it calls the API endpoint for that employee to populate the data on the screen. If instead of WebAssembly you used interactive auto rendering mode, your web application would run in the Blazor Server mode while the WebAssembly is being downloaded, and then smoothly transition over to the WebAssembly mode and start calling the business services via REST API. However, with Xomega Unified Architecture for Blazor applications, you don't have to worry about the interactive rendering modes or commit to a specific architecture. Instead, Xomega allows you to stay focused on implementing the platform-agnostic business logic in a presentation layer for your application. I hope you enjoyed this video, and I would like to thank you for watching it to the end. Make sure to let us know what you think of it in the comments section, and subscribe to our channel for more videos on building business applications in .NET. If you think that our low-code platform Xomega can help you speed up your development process, or if you want to learn more about it, then come visit our website Xomega.Net. You can register there and order a free version if you want to try it out for yourself. We have a complete step-by-step tutorial that you can follow there, as well as full detailed documentation. So happy coding and see you next time.